everyone, this is your J Educator Megha, and I wish you a lot of happiness and success this year, guys. A very happy Diwali to all of you. Um, with this new beginning, new year, I know your entry for your JEE examination has to be double, okay, because now it's been like the exam is very close, and yes, you have to double up your speed. So today we are going to start with the another topic of GOC, which would be the electrophiles versus nucleophiles. Okay, so whenever we do any question of any question of organic chemistry, okay, for any reaction to occur, we should know that where is the electrophilic position and which is going to be the nucleophile. Okay, when you know that this is electrophilic position and this is a nucleophile, then only you will be able to attack. Okay, so nucleophiles are basically nucleus loving species, and electrophiles are usually the electron loving species. Okay, so as when you go through the name of these two things, that is electrophiles and nucleophiles, electro means electron, and phile means affinity. Affinity is basically attraction, or you can say love towards the electron. And nucleophiles means this is nucleus, and the phile means again affinity. So when you will go with the with the meaning of these terms, you will easily be able to understand nucleophiles are basically nucleus loving. So if they are saying that I am a nucleus loving species, I need a nucleus, I need a nucleus. So here if you will be getting a nucleus with protons and neutrons with less number of electrons, so we could say that if here we are having a nucleus. So these are the nucleus affinity, means nucleus loving species. So these species will come towards this particular nucleus and they will say we want you, okay. And electrophiles are basically electron loving species. Electron loving species, so we would say that who would be electron loving? Those who would be having the deficiency of electron. So any of the thing that will be having the deficiency of electron and having a more of positive charge, more of a nuclear charge, that they will be having the attraction for the electrons. Okay, so they will try to attract electrons. So they are basically opposite in nature. So we would learn in today's session how to identify these two different species. Okay, so guys, I will take you through the important points of differences between the electrophiles and the nucleophiles, and then after we will be focusing over many examples how to identify the electrophiles, nucleophiles, and then we will be doing a small exercise. Okay, so here in this exercise you can see that this is a question 1. I have given you few species, that is the Cn negative, H positive, Br positive, AlCl3. Some are charged species, some are uncharged species. So I would love to ask you bache, what out of all these species, they are 8 in number, how many of them are electrophiles and which of the species are electrophiles, okay, which are electrophilic in nature. Similarly, here in this question, I would love to ask you, bache, that out of all these species, which is going to be a nucleophile? Okay, so do you really want to do this exercise? Here, if you would see, the questions are, some of the questions are neutral, some are having a negative charge, some are having a lone pair. Okay, so whether they are, this is exactly a lone pair, or when you will see this particular species, this is having a radical. So what are they? Whether they are electrophilic or nucleophilic? So in which category they would go? Okay, because it is very necessary. And then after, the next thing that we need to learn is the which is a better nucleophile. Okay, you could be having more than one nucleophile, but for the rate of reaction to occur, how fast the reaction will occur, we need to know out of all this which is a better nucleophile. Okay, so for that, to understand the nucleophilicity order, the order of nucleophilicity, I will be giving you one separate lecture. Okay, so here we start with today's discussion. First of all, let's go through the comparison, the basic comparison between the electrophiles and the nucleophiles. Okay, so as I simply said, electro means electron, phile means affinity. So electron and affinity. Affinity means attraction. Okay, and here nucleophiles, nucleus means nucleus which is actually a positive charge thing, and phile means affinity. Okay, So any of the thing that has affinity for nucleus, okay, and any of the thing which has affinity for electron. If you are not able to understand, I would let you know. Guys, simple. Who will show affinity for electrons? So let's say here if I am having an electron. So for this, who will show attraction towards electron? Who will show attraction towards electron? Now tell me, who will be showing affinity towards electron? Affinity means attraction. Who will show the attraction towards electron? Simple, those species which are either having a positive charge, okay, which are having a positive charge, because we know that opposite attracts, you know. So in simple words, we can say that any of the species which is having a positive charge, any of the species which is having a partial positive charge, okay, partial positive charge. So just by looking at the charge, we would say that this is electrophilic. No, this is not a right answer. Basically, any of the species has to be electron deficient, okay. You know the octet rule, so if any of the species is having the incomplete octet, okay, if their octet is incomplete, then only they will show the attraction towards electron. Okay, if their octet is complete, they are already having 8 electrons in the last shell, valence shell, then why would they attract electron? There will be no affinity for electron, there will be no attraction for electron. Are you getting my point? So just by looking at a positive charge or a partial positive charge over any of the species, we can't say that this is electrophilic. We have to see whether this really needs electron or not. So if anything is having a hungriness for the electron, okay, so any of the species must be hungry for the electron, then only it will accept the electron pair. Okay, the octet has to incomplete octet, or you can say that if any of the species is having its octet complete but having the vacant orbitals, like the vacant p orbital, the vacant d orbital, specifically the period number 3 elements, usually have a vacant 3d orbital. So those who are having a possibility to expand their octet by accepting the electron pair, okay, so any of the species, for any of the reason, if it is accepting the electron, showing the affinity attraction for the electron, is said to be electrophilic in nature. Okay, so I could say that species having affinity for electron, they must be electron deficient. Okay, deficient or electron deficient means their octet incomplete. Okay, usually when their octet is incomplete, we would say that they are having the 6 electrons, species with the 6 electrons. Usually the species with the 6 electrons are said to be electrophiles. Now not necessarily if they are having a positive charge, okay, and so of course we know that opposite attracts. So if they will be having a positive charge, so there might be a possibility to become neutral, because neutrality is the key. Neutrality means stability. So if any of the species shows attraction towards the negative charge, is said to be electrophilic. Okay, so any of the thing showing attraction for electron for any of the reason, either because of the positive charge, or because of the incomplete octet having 6 electrons, or because of the reason they are having a vacant orbitals, they are said to be electrophilic. Okay, so I would say guys, any of the species that accepts electron pair for any of the reason is said to be electrophilic. Okay, if I am accepting the electron pair, let's say, let me give you an example. If I am accepting money from any of the source for any of the reason, then yes, I am I am money deficient. Okay, so that's what I would say. So any of the species, if it is showing the attraction for the electron, then it is said to be the electrophilic in nature. So I would conclude in one single sentence. If you want to make it much easier, you simple look for the species with either a partial positive charge. What do you mean by a partial positive? Guys, see, if I give you an example like CH3 Br. Okay, if I give you an example like CH3Br, this is a covalent molecule. Here we are having a sharing of electron. So I can't make it like this NABr. there is a difference in between the two species. Okay, when you will look for this particular species, this is ionic, so I can say that Na is positive and Br is negative. So here Na is bearing a complete positive charge, so because of this complete positive charge I could say that Na is electrophilic in nature. But here in this molecule, this is a covalent molecule. There we are having a sharing of electron between the carbon and hydrogen. There we do have a sharing of electron. So here I would say that there will be a polarity. There, because of the electronegativity difference, this shared pair of electron will be shifted towards bromine. Ultimately over the carbon we will be having a partial positive, and over the bromine we will be having a partial negative. Okay, so this is what I mean about the positive charge. So here in this example I can say that CH3 positive, this is my electrophile, and Br negative, partial positive, and Br is going to be partial negative, is my nucleophile. Got it? So partial positive charge species are going to be electrophilic. Okay, this is also showing that there is an electron deficiency. Any of the species with complete positive charge, or any of the species which is having a vacant p or d orbital. Usually we do have species from the period number 2 and the period number 3 which are having the vacant p or d orbitals. There could be many examples, guys, so you need not to be worried about. Yes, if you would say BH3, this is a 6 electron species and having a vacant p orbital. If you know bonding, you can easily understand it is having vacant p orbital. That's why this is electrophilic. I would say that AlCl3, yes, in the case of AlCl3, here again I am having a vacant p orbital. If you would say SO2, in the case of the example SO2, the p orbital is not vacant. This is also a period number 3 element, but here we are having a vacant d orbital. Okay, its octet is complete, but still SO2 is electrophilic in nature. Reason being, in the case of the SO2, sulfur is having a vacant d orbital. It is a period number 3 element. So this is all about the bonding. If you know bonding well, if you know the hybridization, you will get to know that whether it is having a vacant p or vacant d orbital. Okay, so sulfur in its valence shell electron, it is having 6. It does share the electron with the oxygen, and so therefore it octet gets expand. Absolutely. If you would see here in the case of SO2, the octet is it has an ability to expand its octet. Still, it is having a vacant d orbital. So yeah, this could be considered to be electrophilic in nature. Okay, so this is the point which I want to make. Now nucleophiles are just opposite of it. If the better you understand the electrophiles, the better you will be able to understand the nucleophiles. Now what is the difference between the nucleophiles? Simple, go with the definition which I just shared with you. Nucleophiles are nucleus affinity, means they are nucleus loving. Now tell me, what are those species? Those are who are going to be nucleus loving. Who are those species? Those who say that, oh, I want to love nucleus, I want to go to nucleus. Who would be such a species? Such a species would be those who are having a negative charge, because we know that nucleus is strongly positive. Nucleus is having a neutral neutron but a positively charged proton. So it is having high positive. Okay, so who will go towards the positive charge? Who will go towards the nucleus? Any of the species, those who are having more number of electrons, any of the species, those who are electron rich in nature, will go towards a nucleus, will show affinity for the nucleus, and so therefore they would be considered to be nucleophiles. So any of the species having affinity, affinity means attraction, or you can say that love for nucleus. In simple language, any of the species that shows affinity, attraction or love towards nucleus. Now who can show love towards nucleus? Any of the species which is electron rich. Absolutely, any of the species which is electron rich, having more number of electrons, could be considered to be nucleophiles. Any of the species that shows attraction for the positive charge, because neutrality is the law. Any of the species which is bearing a negative charge will show attraction towards the positive, because opposite attracts like repels. Okay guys, so any species that attracts towards positive charge is said to be nucleophilic in nature. I will be giving you examples, so please don't worry. First, go through the points of differences. Now if any species is nucleophile showing attraction for nucleus, then definitely it will be having a tendency to give its electron pair, right? So we can say that such a species donates electron. They accepts electron and they donates electron. Okay, these are the species with 8 or more number of electrons. If they are showing attraction for the positively charged nucleus, then absolutely they have to be electron rich. They have to be with their complete octet. So these are the species does not have less than 8 electron. If they would be having less than 8 electron, they would be considered to be electrophilic. So these are the species with 8 or more number of electrons. Yeah, absolutely. They could have more number of electrons or 8 number of electrons. Okay. These are the species with either the partial negative, completely negative, okay, partial negative, simple. Here in the case of the CH3Br example, when I took that particular example CH3Br, you can say that this Br is having a partial negative charge. Okay, this is said to be a nucleophilic in nature. If I am taking an example of NaBr, here you can say that Br negative is going to be nucleophilic in nature. It is having a completely negative charge. Any of the species with a pi bond or a pi bond, whether it is of double bond, triple bond, or any of the pi bond, or this pi bond is of a benzene, they all are going to be nucleophilic in nature. And guys, if any of the species is also bearing a lone pair, what do you mean by a lone pair? You seen an example of ammonia? In the case of ammonia, nitrogen is sharing 3 electrons with the hydrogen. If you will draw the structure would be like this. Okay, so here we are having how many number of electrons? Its octet is complete. Its octet is complete. There is a 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Okay, so octet is complete. And other than the octet, here we have 3 bonded pairs and 1 lone pair. So this is a free pair of electrons. So it will be easily be able to form a coordinate bond. Okay, so this lone pair can easily be given to any of the species with a highly charged nucleus. Okay, and so therefore this is said to be nucleophilic in nature. Okay, so any of the species who is having a lone pair is said to be nucleophilic in nature. I hope the points of differences are very clear. If not, then you please rewatch it. You will be able to know. Now, let me make you understand with the help of the examples. So, what I just said for the electrophiles, they are simply. Let me change the color to red. Red would be better there, right? Species, first of all, these are the species with a less than 8 number of electrons. Their octet could be incomplete. 6 electron species, I could say that 6 electron species having a partial positive, having a completely positive, or having a vacant p or d orbital. Okay, so I have summarized it in simple these terms. So let's figure it out whether they are electrophiles or not. So here I could say that H positive, Cl positive, Br positive, if you will see their octet is incomplete. They all are 6 electron space. In their last shell, in the valence shell, we are having a 6 electron. Here we are having 0 electron. Okay, in the case of the Br positive, again we are having 6 electron in the valence shell, not the complete 8 electrons. NO2 positive, CH3 positive. So any of the positively charged species are said to be electrophiles. PCl5. Now you would say, ma'am, PCl5 is not having any charge. So whether it is electrophilic? Yes, absolutely. The PCl5 is electrophilic. Why? In the case of the PCl5, its octet is complete, and even it is having the expanded octet. Okay, more than 8 electrons, but still, because over the phosphorus we are having a vacant d orbital. So because of the reason we are having 5 chlorine, yes, it has expanded octet. It has more than 8 electrons. It has basically 10 electrons. Okay, but still, because of the reason it has a vacant d orbital, its octet is it has a tendency to accept electron, and so therefore this is considered to be electrophilic. I have already given you an example of SO2. SO3, they all are having a possibility of the vacant d orbital, and this is a boron. This is a period number 2 element. In the case of the BH3, if you would see and you will draw the structure, you will find that in the case of the boron you are having a vacant p orbital. So vacant p orbital plus the boron is a 6 electron species here. So this is said to be electrophilic in nature. Guys, not only these, even the carbines are also the 6 electron species. Okay, their octet is also incomplete. They also have a vacant p orbital, and so therefore carbines are also considered to be the electrophilic in nature. Okay, let me give you more example. So here, if you will see the example number 1, you will find that in the case of the HX, you can see that because of the electronegativity difference, there is a polarity, and because of the polarity, the electron pair will prefer to shift towards the halogen side, because halogens are more electronegative, and so therefore this will bear a partial negative, partial positive. So this is a electron deficient species said to be electrophilic, and this species has become more electron rich, bearing a partial negative, said to be nucleophilic. So this part is said to be nucleophilic. So understood. So here, if you would see any of the species bearing a partial positive, partial or complete positive is said to be electrophilic. Any of the species bearing a partial negative and a complete negative charge is said to be nucleophilic. Just opposite. Okay. Now, here in the case of second example, which I already discussed with you, the example of CH3Br, this is carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. The carbon is having an electronegativity difference. Carbon is 2.5, I agree. Hydrogen is 2.1. There is an electronegativity difference. But if you will see the carbon and you will see the bromine, you will find that there is a much electronegativity difference. If I would say that fluorine is 4, then it is going to be 3, and then it is going to be 2.8 something, or 4 then 3 will be the electronegativity of that bromine, actually 3 or 2.8 something. Okay, so if you will see that the carbon and the bromine is having a more electronegativity difference, and because of this reason, the bromine, the halogen, will try to pull the electron pair, and this will become partial positive and partial negative. So this partial positive is said to be electrophilic, and this partial negative is said to be nucleophilic in nature. Okay, this is it in the case of the covalent compounds. Now what about the ozone? Guys, if you will see the exact structure of ozone, you will find that O and O are forming a double bond with each other, with 1 2 3 4 5 6, 1 2 3 4 5 6, this much of electron, and one of the oxygen which is also having 1 2 3 4 5 6 electron. Here this oxygen is giving its electron pair like this. Basically here we are having a coordinate bond. Okay, this oxygen is having a lone pair and this oxygen is having a deficiency of 2 electrons, so therefore there is a formation of a coordinate bond. So ultimately we usually draw the structure of ozone like this: O double bond O, and like this. Okay, so when you will replace this, you can also show this coordinate bond as a dative bond, and you can say that here we do have a positive charge and here we do have a negative charge, because this sign is showing you that the electrons are moving from this to this. So ultimately this will become positive and this will become negative. Okay, now if this is positive, we can draw its resonating structures. So if we want to draw its resonating structure, this pi bond will be broken to neutralize this oxygen atom bearing a positive charge. Ultimately this will become positive and this will become neutral. So here we would say that when we will draw this kind of structure, we would say that one of the oxygen bearing a positive charge is said to be electrophilic in nature, and the another oxygen which is bearing a negative charge is said to be nucleophilic in nature. And so therefore oxygen has both the properties. This can act as an electrophile and this can even act as a nucleophile. Okay, so this is a big thing. Now the example number 4, this is the example of a carbene. Okay, guys, you know that the structure of a carbene is something like this. Okay, so here the carbon is having a 6 electrons, 1 2 3 4 and 5 6. Okay, 5 6. And here we are having a vacant orbital. So because of this vacant orbital, vacant p orbital, this carbon could only have a p orbital. Carbon, it's a period number 2 element, so this cannot have a vacant d orbital. Okay, so because of this vacant p orbital, this has a tendency to accept the electron pair easily, and so therefore it is said to be electrophile in nature. Okay, this can show the attraction for the electron, easily accept the electron pair, said to be electrophilic in nature. Okay, so this is the same structure of carbene. I have just simply shown that what is about the CH3 as a carbene. Okay, so yeah, this is electrophilic in nature. Now here I have given you one more example. BF3 is also electrophilic in nature. You know, in the case of the BF3, what happened? Here, this is the bonding of the BF3, 1, 2, 3, 4, 5, 6. This is a 6 electron species, but for the sake of the boron to complete its octet, here fluorine shows a back donation like this. So ultimately, why there is a back donation? Reason being the fluorine is having a lone pair and the boron is having a vacant p orbital. So reason being here we are having a vacant p orbital. This boron is said to be electrophilic in nature. So any of the species showing tendency or showing affinity for electrons, showing tendency to accept electron is said to be electrophilic in nature. Whatever be the reason, either a positive charge, either a partial positive charge, or either a incomplete octet or a complete octet, but a vacancy for the upcoming electrons. But the presence of vacant p or d orbital. Okay, because ultimately your octet is complete, but still you are accepting electron. Okay, irrespective of the octet is complete or not, if any of the species will accept electron is said to be electrophilic in nature. Got it? That's why all the species which are Lewis acids are said to be electrophilic in nature. Now let's have a look over the nucleophiles. Let me show you the very good examples of nucleophiles. Guys, when you see nucleophile means having affinity for nucleus. So those species, those who are going towards positive charge. Now who will go towards positive? Who will run towards positive? Any species which is having a complete negative charge, any species which is having a partial negative charge because opposite attracts, any of the species bearing a pi bond, okay, pi bond, whether the pi bond is of a double bond, triple bond, or of a benzene, of anything, okay, or any of the species having a lone pair of electron. So if they are electron rich, if these species are electron rich, they will run towards positive. And because they are running towards positive, they are running towards nucleus, they are said to be nucleophilic in nature. Okay, so let's see the examples of nucleophiles. Simple terms I just said to you all of you. Like if you are having the examples like NaBr, I can say that here the Br negative is said to be anion. Okay, every anion, any of the species bearing a negative charge is said to be nucleophilic. The OH negative, the Cn negative, I negative, Cl negative, Or negative, Rs negative, they all are having a negative charge, are said to be nucleophilic in nature. Now, any of the species having a pi bond like any alkene, okay, any alkene, or any alkyne, here we do have two pi bonds. Yes, they are said to be nucleophilic in nature because more number of electrons. Pi bond is a weak bond. This can easily be broken and can be broken easily and can give its electron pair to any of the other species. So any of the other species means any of the species with a nucleus. Okay, with the nucleus. So we know that the pi bond usually forms by the sidewise overlap, and if they are having a sidewise overlap, so this bonding is very weak. So this bond can be broken very easily, and so therefore they are said to be nucleophilic. Here in the case of a benzene, yes, they are also said to be nucleophilic. Got it? Now, here I do have many other examples like H2O. If you will see the H2O, these are the species bearing a lone pair. In the case of the H2O, we don't have only one lone pair, there is a two lone pair. But guys, whenever any species is said to be a nucleophilic in nature, doesn't matter whether it has one lone pair or two lone pair. Ultimately, any species can only give one pair of electron at a time, not more than one electron pair at a time. Okay. So quantitative estimation doesn't matter whether you have one electron pair, two electron pair, three electron pair. Doesn't matter. If you would see fluorine, you would say, ma'am, over the F negative, I do have 1, 2, 3, 4, 5, 6, 7, 8. I do have 8 pair of electrons. So F negative is a better nucleophile. No. Okay, so number of lone pairs doesn't decide whether it's a good nucleophile or a bad nucleophile. Okay, the nature of the species, the tendency to give the electron pair actually decides. Okay, I'm very rich. I do have lot of money. Okay, I do have so many. I have so many shares. I have so many holdings, and I'm very rich. Doesn't makes me that I will be a good donor. Okay, so to be a good donor, this is a tendency of a person. Okay, a person with small holdings, small money could have a better donating ability rather than having a person with more rich, more pesa, more money would be a good donor donating ability. Okay, so electron giving ability or money giving ability comes from the nature of the atom, from the nature of the person. It doesn't comes from how rich you are. Okay, so quantitatively, these number of lone pairs are not going to decide which is a good nucleophile or bad nucleophile. And yeah, this is our topic which I will be taking in another class, another session. There I will let you know how to decide. Okay. Okay, so here, yeah, these are the species. Their octet is complete. They are the 8 electron species, and they do have a pair of electron, free pair of electron, can easily participate in bonding, and so therefore they are said to be a good nucleophiles. Here, in the case of the species which is triphenyl phosphine, we call it triphenyl because these are the phenyl rings, triphenyl phosphine. Phosphine. You might know we do have a structure like pH3. So if I replace the hydrogens by the phenyl, then it is said to be triphenyl phosphine. Here also we do have a pair of electron. In the case of ammonia also we do have a pair of electron. In the case of any kind of ketone or ethers even ethers, we do have a pair of electrons. So when any of the species is having a pair of electron is said to be nucleophilic in nature. Yes guys, so here you would say that ma'am, in this case I do have this pi bond also and this is a lone pair, then why you are saying this lone pair will be a nucleophilic in nature? Yes guys, see, if you do have a negative charge, if you have a partial negative charge, if you have a lone pair and if you have a pi bond, then relatively the species with negative charge are more nucleophilic because they want to neutralize themselves. Then the species with partial negative. Then comes the species with lone pair because they have a free lone pair, which is bonded with only one atom. So it is under the influence of only one atom. Okay, only one atom. But this pi bond is under the influence of two atoms. Okay, so this is a better donor rather than any of the species with a pi bond. Got my point? So that's how, if you have a species with a pi bond and you have this lone pair as well, then the lone pair over the oxygen will consider to be a better nucleophile. Okay, so yeah, this is how the reactions becomes easier when we know all of such things. Now guys, the last thing, the polar molecules. Polar molecules, basically because of the polarity, because of the electronegativity difference, we do have a partial negative charge. Just like here in the case CH3Br, I could say that this is partially negative and this is partially positive, right? So ultimately Br negative is said to be nucleophilic. Similarly, in the case of Grignard reagent, this is CH3MgBr. Guys, this is a Grignard reagent. This is a Gilman's reagent. Okay, you will be doing the reactions related to that. I will be giving you all such name reactions in my upcoming sections. Okay, so Grignard reagent, Gilman's reagent. If you would focus over these kind of reagents, you will get to know that this part, this carbon is more nucleophilic in nature. Why? It is bonded to a metal. Magnesium is a metal. This is a positively charged species. So ultimately, relatively, this is nucleophilic. Getting my point? Okay, so if it is positive, this is said to be negative. So ultimately, this is wearing a partial negative charge is said to be nucleophilic. Similarly, copper is again a metal, so relatively copper and this must be any carbon containing part. So carbon and copper is metallic, carbon is non-metallic. This is positive, this is negative. So this part is again a negative. That is a nucleophile. It is more electron rich, will show affinity or attraction for the nucleus, ultimately becomes nucleophilic in nature. N-butyl lithium. N-butyl lithium means we are having a carbon-carbon-carbon chain and it is being associated with lithium. Lithium is again a metal, will be a non-metal. This will be nucleophilic. Zinc is again a metal, this part will become negative, this is nucleophilic. So all such species are said to be nucleophilic. So whenever you have any electronegativity difference, see the species with a partial negative charge. Now it's a time to do a bit of exercise, and I believe my students are going to enjoy this particular exercise. And guys, if you want to know any of the thing, and if you have any other doubt or any molecule you are struggling with, ma'am, it is electrophilic or nucleophilic, I really get confused in this particular molecule, do let me know. Okay, I will help you on this. But my belief is, after doing this simple exercise, you will not left with any of the confusion. Okay, so let's begin with it. So to do any question, first of all, you must know the bonding. Okay, you must know where the electrons must be. The very first question. Let's begin with it. The option number A. You know, cyanide. A carbon is having 4 electrons, 1, 2, 3, 4. A nitrogen is having 1, 2, 3, 4, 5. So carbon, what does a carbon do? Carbon says, okay, I will be sharing electron. So nitrogen is having already 3, 4, 5, 6, 7 after sharing. So over the nitrogen, we do have a negative charge as well. If nitrogen is bearing a negative charge, this means that there is an addition of 1 more electron. Ultimately, nitrogen says, okay, I do have 1, 2, 3, 4, 5 electrons I was already having the valence shell. Because of this negative charge, I do have 1 more electron, and yes, from the sharing I do have 2 more electrons. Ultimately, my octet is complete. Nitrogen says, oh yes, my octet is complete. What about carbon? Carbon says, I do have 4 electrons in my valence shell, there is no charge over me, and I do share 2 electrons from the nitrogen. So 4 plus 2 is 6. Oh, carbon is like, I'm deficient. So what happens is, nitrogen is having a pair of electrons. So nitrogen do a back bonding with the carbon. Ultimately, when it does the back bonding with the carbon, this structure gets complete, and this coordinate bond can easily be replaced by a single bond. Okay, so we show it like this. Okay, so this is the structure of cyanide species. So if their octet is complete, ultimately because of the back donation, the carbon's octet is complete, nitrogen octet is complete. So they are the 8 electron species. This is also 8 electron, this is also 8 electron, and ultimately they are bearing a negative charge, so they are said to be nucleophilic. Now you tell me, is this electrophile? No, this is not electrophile. Because of the back donation, its deficiency is getting completed. Ultimately, it is bearing a negative charge. They both are 8 electron species. This is said to be nucleophiles. So no, this is not nucleophile. Is this no? This is not electrophile. This is not electrophile. Actually, this is nucleophilic in nature. In the case of option number B, this is H positive. We do have 1s0 electronic configuration. 1s0 means what? Showing affinity for electron. It is saying I am vacant. I don't have even 2 number of electrons to complete my s orbital. Okay, a maximum number of electrons that can come into the 1s orbital is 2, and it is not even having such 2 electrons. So showing attractions for the electron, it will show attraction for the electron very quickly. So this is electron loving, having affinity for electrons. Ultimately, it is said to be electrophilic in nature. Okay, got my point. Electrophilic in nature. Don't just go in rush scheme. Okay, ma'am, positive charge electrophile. No, this is not a right way. Okay, please let us learn sensibly, at least this time. Okay, because you're going to hit the JEE paper. Okay, not any ordinary paper. So please be cautious. This is Br positive. Again, in the case of the Br positive, it is ultimately a deficient orbital, because when you will see the bromine comes in fluorine, chlorine, and bromine. That is period number 4. So this is going to be 4s, 3d, 4s2, 3d10, and 4p. In the 4p, we do have generally 5 electrons, but because here we do have a positive charge, this will not be, will be having the 5 electrons. This will only be having the 4 number of electrons, because there will be the loss of 1 electron. Ultimately 4p4. So here when you will see the last shell, the fourth shell which is the last shell, the total number of electrons are basically 4 or 2, that is 6. In the last shell we have 6 electrons. These are the valence shell electron. So its octet is incomplete. Its octet means the number of electrons which are available in the last orbital, last shell, is incomplete, that is 6. This could have 8 electrons. So this is said to be electrophilic in nature. This is said to be electrophilic in nature. When you will see the example of AlCl3, that is the option number D. In the case of the AlCl3, when you will draw the structure, this would be like this. AlCl3. Over the aluminium, we do have a vacant. This comes from period number 3. This is having a vacant p orbital. So because of this vacant p orbital, yeah, Al2Cl6 is not electron deficient, but this is AlCl3, which is actually a Lewis acid. So because of the vacant p orbital, this is said to be electrophilic in nature. I told you, yes, because of the vacant orbitals, they could be. In the option number E, in the case of option number E, the BH3, I hope you people are doing before me, right? Okay, so BH3, when you will see BH3, this is also having a 6 electron. This is a 6 electron species, octet incomplete, simple, a vacant p orbital. Okay, so many reasons for a species to be electrophilic. So this is also electrophilic in nature. Okay, now if you will see the option number F, in the case of F, what you are having over the carbonyl carbon, there is a positive charge. So is this positive charge stable? No, this positive charge is not stable. This positive charge says that I need to be neutralized. Okay, so do something. Here I do have only 1, 2, 3, 4, 5, 6 electrons. So this carbon is simply having 6 electrons. Its octet is not complete. So this is said to be electrophilic in nature. Absolutely, this is said to be electrophilic in nature. If you will see the option number G, here you will say that this is ammonia. Here in the case of ammonia, is this electrophilic in nature? How guys, this is having 1, 2, 3, 4, 5, 6 and 7, 8. This is an 8 electron species, and yes, this nitrogen comes from period number 2, and the period number 2 elements, that is the 2s2, 2p6. So it has a complete octet. There is no possibility in the second shell we don't have any vacant orbital, we don't have any 2d. Okay, is there you do have any 2d? No, we don't have any 2d orbital. Its octet is complete, so this cannot be electrophilic in nature. No, this is not electrophilic in nature. It has a complete octet and there is no vacant orbital, no partial positive, no complete positive charge. It is nucleophilic. Okay, so yes, this is said to be nucleophilic in nature. A last option, that is the HO. If you will see the structure of NO2, you will find that here the NO2, nitrogen is having a lone pair 1, 2, 3, 4, and over the nitrogen we do have a 5 electrons, right? We do have a 5 electrons, but because of the positive charge we do have only 4 electrons, that is 1, 2, 3, 4. Okay, and how we will be having a one more oxygen atom if you will draw the structure of NO2 positive. So here in the case of the NO2 positive, we would see that over the nitrogen we do have 4 electrons. So definitely this nitrogen will form this kind of coordinate bond bearing a positive charge. Okay, nitrogen is having a 4 number of electrons because it has 5 electrons, but because of the positive charge there is a loss of 1 electron, ultimately 4 electrons. So 4 electrons means 1, 2 and 3 and 4. So these 2 electrons will form a coordinate bond with this oxygen atom and they are forming a covalent bond. Ultimately, when you will see the total number of electrons over the nitrogen, you will find that it has a total of 6 electrons. Okay, that is 1, 2, 3, 4 and 5, 6, which are undergoing the coordinate bond formation. So this is again a 6 electron species and octet incomplete, bearing a positive charge. Absolutely, we would say that this is electrophilic in nature. This is electrophilic in nature. Okay, so this is how we can identify that these are the species. So many of the integer type questions can also come from this part, and they would ask you these are the species, out of all those how many are electrophiles in nature. So your answer would be 1, 2, 3, 4, 5 and 6. 6 species are electrophilic in nature. 6 has to be your integer answer. We do have one more simple exercise, and here you have to identify that which of the following are going to be nucleophiles. Let's figure it out. Okay, because not necessarily that there will be charge and you will simply say, ma'am, this is nucleophilic. No, these are the some of the species are having a negative charge, some of them are not, some of them are not. So whether they are nucleophilic or not, guys, do I told you that only one single thing you have to see the charge for the nucleophilic? No. There could be a lone pair, there could be a pi bond, there could be partial negative, there could be partial positive, partial complete negative. Okay, so here let's see the option number A, that is the HS negative. In the case of the HS negative, when you will draw the structure, we do have sulfur with 1, 2, 3, 4, 5 and 6 electrons. So here sulfur is sharing one more electron with the hydrogen, getting 7, and because of the negative charge it is getting 8 number of electrons. If you will see here, hydrogen is having 2 electrons. Yes, absolutely, hydrogen can have maximum of 2 electrons because this is a period number 1 species, so this can have maximum of 2 electrons in the period number 1. That is the n is equals to 1 shell. And the sulfur, because of the sulfur is having 6 valence shell electron plus 1 because of this negative charge and plus 1 because of the sharing of electron. Its octet is complete. It is a 8 electron species. So its octet is complete. Its octet is complete. This is a negative. This is a negative charge. Please don't be confused. This is negative. Okay. Okay, so this is having a complete octet. So reason mean its octet is complete octet. It is a 8 electron species. It is said to be nucleophilic in nature. Yeah, we would say that you are nucleophilic. Done. Now here in the case of the BF3 we already done in the previous question. BF3 usually have this kind of structure, and in the case of the BF3 we do have a vacant orbital. That's why the fluorine forms a back bonding with the boron. Okay, so ultimately the presence of this vacant p orbital over the boron shows that I am accepting electron. So this is accepting electron pair. So any of the species that accepts electron pair, so those who accept electron pair show affinity for electron are said to be electrophilic in nature. So this is electrophile, not nucleophile. So this BF3 is not nucleophile. This is electrophilic in nature. Now here in the case of the C, option number C, if you will draw the structure of C2H5OH, you will find that this is CH3, this is CH2, okay, and this is O and H. Over the oxygen we do have a lone pair of electron, and here oxygen, yes, absolutely, not the carbon but the oxygen, because of the presence of lone pair of electron and its octet is complete. You can see the total number of electrons. It has 8 number of electrons. Octet complete. This is the 8 electron species, and because of the lone pair of electron, this is said to be nucleophilic in nature. This can easily go at any positive charge. This can show the affinity for the nucleus. Okay, so that's why we would say that you are nucleophilic in nature. So this is nucleophilic. Not necessarily that in the question I will show you that here is the lone pair. Okay, you have to do this your own. You have to figure it out. You have to draw the structure. Okay, now in the case of option number D, whether it is nucleophilic or not, let's figure it out, guys. This is nitrogen. Here we are having free carbons 1, 2, 3, and the question is like, here we have methyl. Now the question is not asking you whether it is a good nucleophile or a very bad nucleophile. We are simply asking this is a nucleophilic or not. So guys, when you will see the structure, nitrogen is having its complete octet. This is a 8 electron species. And if it is a 8 electron species, this can never be electrophilic. Absolutely, this is a 8 electron species and this is nucleophilic in nature. Reason being, it is bearing a lone pair. This species is bearing a lone pair, and because of this lone pair, this is said to be nucleophilic. This can easily give its electron pair to any positively charged nucleus. So this could be nucleus loving. Okay. So here bonded pair or lone pair? Of course, lone pair are free to be moved. Okay, they are freely movable under the influence of only one nucleus. They are easy to be given. Okay, so this is said to be nucleophile. Absolutely, the answer is yes. This is a nucleophile. Now, when you will draw the structure of option number B, and absolutely, I am very sure you will do a mistake in this particular question. Guys, this is not CH3. This is CH2. So when I am saying that this is CH2, please draw the structure and there is a pair of electrons. So when you will count the total number of electrons over this particular species, no, this is not a wrong structure, this is the right species. This is 1, 2, 3, 4, 5, 6. So this is a 6 electron species. So if this is a 6 electron species, many of the students says that, ma'am, this is a lone pair. No, this is not a lone pair. This is an inactive, non-bonded pair of electron. This is an inactive non-bonded pair of electron. You can say that this is lone pair. Okay, why? Because this is a 6 electron species, its octet is incomplete, and this is also having a vacant p orbital. Okay, so rather than giving you the electron, it will try to accept the electron. It will try to accept the electron. So when it is trying to accept the electron, because its octet is incomplete, it is said to be having affinity for electron. It is said to be electrophilic in nature. So guys, this is a carbene. This is an example of carbene, which is a 6 electron species. I already shown you while doing the exercise. Okay, so this is said to be electrophilic in nature. So this is not a nucleophile. Now, if you will see the option number F, what you will learn from the option number F, in the case of option number F, we have carbon with hydrogen, 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 and this is a one single pair of one single electron. So this is a radical. This is having 1, 2, 3, 4, 5, 6, and 7. So this is a 7 electron species, that is an odd electron species, and the odd electron species are also said to be, yes, it's Diwali, that's why we have this kind of sound. But you people and I, we basically learn, and yes, absolutely, this N2 has to be there, because Diwali will come every year, but your JEE exam is going to be happen only 1 year. Okay, so I want that you qualify it in one single. Okay guys, so please make sure you utilize your time more efficiently and more actively. So ultimately what I was telling you, this is a 7 electron species or an odd electron species. Yeah, this is a radical. Yes, absolutely, this is a radical. But yes, we could say that this is also electrophilic. Ultimately it's deficient. In absolute terms, this is a radical. But yeah, this is also showing attraction towards electron. So this could be considered as electrophile also. Okay, if needed. Now here we do have the last option to go with, that is CH3 and N with 1, 2, 3, 4. Please draw the structure the way I have given to you. If you will draw this particular structure in another way, like carbon with 1, 2, 3 hydrogens, this is nitrogen. Here we do have 1, 2, 3, 4. Okay, this is the structure. Now if you will see the carbon, this is a 8 electron. 1, 2, 3, 4, 5, 6, 7, 8. But if you will see the nitrogen, please find it. Are these the lone pairs? No guys, these are the inactive non-bonded pair of electron. Again the same thing. Why? Because they are 6 in number. The nitrogen is a 6 electron species, and when nitrogen is a 6 electron species, how it could be a nucleophile? No, this is deficient. See, 1, 2, 3, 4, 5, 6. So this is deficient. So any of the species, when it is deficient in electron, not even having its octet complete, having a vacant p orbital, it is said to be electrophilic. It is said to be electrophilic. It will show the attraction for electrons. It will first accept the electron to complete its octet. Okay, and if it is showing attraction or affinity for electron, it is said to be electrophile. Okay, so absolutely I would say that this is electrophile. They both are electrophiles, not nucleophiles. So please mark it. This is also electrophilic in nature, not nucleophile. So out of all those species, which are how many of them are nucleophilic? 1 bearing a negative charge, then this C, 1, 2 with a lone pair. Okay, 1, 2. Here the third one with a lone pair. 3. Only 3 species. So if this kind of question comes in your integer type, your answer has to be 3. Yeah, the option number E, option number F, and option number G will confuse you. Okay, but they are not nucleophiles. Okay, so if you will draw the structure carefully, you will be easily be able to do. The next session that I will be coming up with the order of nucleophilicity, and I will be comparing it with the basicity. Many times students gets confused between the nucleophilicity and basicity, which is a good nucleophile, which is a good base. Okay, because they both are having a negative charge. When you write a base, yes, they are also the electron rich species. If you write the base, they are also the electron rich species. If you will write the nucleophile, they are also electron rich, and they are also electron rich. So what's the difference between a base and a nucleophile? So basically nucleophile attacks over any of the positive charge other than hydrogen, any positively charged species, but other than hydrogen, but here the base attracts over a positive charge over hydrogen. Okay, so any species with a negative charge, electron rich, accepts H positive is said to be a base. But when any of the species that attracts over, whether it is C positive or whether it is any kind of species like P positive, okay, so when there is an attack over any of the species other than hydrogen, then it is said to be nucleophilic. Okay, so are they the same? No, they are not the same. 90% of the cases you will find that the order of basicity and the order of nucleophilicity is same, but it gets different, okay, in 10% of the cases. So what are they? I will be discussing with you in the next class, in the next session. So guys, if you really enjoyed this session and you got to know how to identify electrophile or a nucleophile, don't just go with over the charge. Many of the students do this mistake and this is the blunder, okay? Please don't do that. Look for the vacant orbitals also. Okay, so this is it. Please do hit like, subscribe for my channel, and share if this session really helps you. And you can follow me on Unacademy for more such sessions, the complete coverage of organic chemistry and as well as inorganic and physical chemistry in English language. Absolutely, I'm your J educator and I'm teaching you Unacademy from last 5 years. Okay, and today is a great day because today is 27th of October and I have completed my 5 years on Unacademy. So it's a big day for me, and yes, I do wish you a very good luck. Okay, and you do follow me on Unacademy for more such sessions, for more such courses. There are many upcoming courses which I am going to come up with. So guys, you can see that here are 127,000, means you can say that 1 million plus students have already learned through me, and they have given so many heads to me. These are the feathers that they have given to us, to our caps, and I do have a 32 million watch minutes. This is the time for which the students have watched my lectures over the time. So guys, this is a big thing for me, and absolutely, if you really want to hit your JEE examination with a full go for a full enthu and you want to build interest in organic chemistry, then my sessions would be awaiting you with a big heart. So please do come and do let me know in the comment section if any of the thing is coming to your head, if any of the lecture you want, or any confusion, any doubt, any guidance you need. Please do come up. I will definitely help you in any of the other way. Okay, thank you guys, thank you, just a big smile. This is what I expect from you. Bye bye, take care, see you some other day.